So, good afternoon once again, and welcome to your subject in CPT3 Fundamentals of Crop Science. So, this is in continuation of our chapter on planting methods, and this time we're going to finish the chapter under planting methods for upland crops. And when we say upland crops, this includes rice, corn, and legumes, since there's also upland rice. So there are ways wherein we can actually ways on planting methods for upland crops. That includes the broadcast seeding, wheeling seeds in a row, or hill seeding in a row. And this entails spacing, seeding rate, and seed requirements. So when we say seeding, one is broadcasting, wherein there is an even spreading of seed on the top of the seed bed. It can be done through manual or mechanized. Another way is drilling, wherein seed is deposited in a row at a uniform depth in a seed bed using equipment. And using this, there's greater seeding and precision. So you have seen this in the first video on the previous discussions and videos that we have on rice production. So this is a seed driller that is found in the field rice in Nueva Ecija. So as you can see, the seeds are being deposited here and they are ready for drilling in the field in uniform distance. So there are actually ways of computing the number of plants per hill, especially in hectares. So we call this hill method of planting, wherein you compute how many plants per hectare do you need. And so you just compute the 10,000 square meter over the hectare over per hectare. So over the distance between furrows in meter and the distance between hills in meters. So when you say like 10 by 20 centimeter, so that's 10 times 20, it's that's 200 meters times as you divide it times the number of plants per hill. So let's say you will plant like 3 or 5 tillers per hill. So that's how you compute the plants per hectare for the hill method. So an example here is a corn space at 75 centimeter between rows and 50 centimeter between hills, and maintain at 2 plants per hill. So 10,000 divided by 0.75 times 0.5 times 2 is equal to 53,300 plants per hectare. That is the amount of seedlings that we need to have. So another computation is drill method of seeding, and it's just about the same formula, but the computation involves the plants per hectare is the same here, 10,000 per square meter, 10,000 square meter per hectare over 1 meter times the distance between furrows and meter, and multiplied by the number of plants per linear meter. So this 1 meter is common, and so you have here an example for mung bean drilled at 30 seeds per linear meter, and rows are spaced at 50 centimeters. So you divide 10,000 by 1 meter times 0.05 times 30 plants. It's equal to 600,000 plants per hectare. So this is a very old actually planting calendar, and since we are now on the era of climate change, so this may differ not depending on actually on the climate. So for example, for these crops, vegetable crops from ampalaya to tomato, So the planting season in the first row is the ideal, and the second row is off-season. So the ideal season for Ampalaya actually starts from October to March, and off-season is June to November. For bush bean, also from November to March, and off-season from July to October. And same with corn from April to September, off-season and ideal on October to January. So this also we also have gabi, even gabi or taro have its own ideal off-season and ideal season. So from January to June and from June to November. So most probably, most of these crops have two seasons, except for tomato. You can have, for tomato, you can have month of February to May, and from June to September, and from October to January. So the rest are two seasons. And also for rice. So for rice, we have first season is the ideal season starts on June, and the only ideal season, and the December for the second cycle of ideal season. So planting guide also have its own row spacing. These are the most vegetables usually, but most of them actually have the same, more or less, inches between plants and between rows. So for example, we have asparagus. So we use 7 crowns, and it's planted in between 18 to 24 inches, and in rows 36 to 48. And these are good for 3 years with a 3 to 4 pounds yield per 10 feet of row. So these are all the planting distance of different crops. So which usually range from, depending actually on their canopy diameter. For beets, like from 2 inches, and in their rows is from 12 inches and so on. So can you imagine using ruler? It's commonly for plants, and also it takes like more than 2 months to 3 months, 4 months to, most of this vegetable takes 3 to 4 months for harvesting to occur. Okay, so another group of vegetables from okra to watermelon would also need like 2 inches or more to 12 inches or more spacing, with about 2 to 3 to 4 months for harvesting. So there are actually different types of planting system when we deal with fruit and plantation crops. So we have first square, quincunx or diagonal, and hexagonal or triangular, and the contour system. So the square is the most common of planting system and is used if filler trees are added in the future, like 1 filler between row and 1 filler between trees in a row. So we can actually compute on how many number of trees or seedlings we need to plant in a hectare. So the formula is the number of plants is equal to area over the planting distance in square meter. So that's for example, just for example, if if you have an area of 10,000 square meter, no, that's a 1 hectare. So 10,000 divided by, like, if you want to plant a coconut for 6 by 6 square, or let's say um, 5 by 10 by 10 square meter, which is 100, 10 by 10 square meter. Let's say, although you can plant coconut for about 6 by 6 only, but let's say you choose 10 by 10, so that's 10 square meter. So 10,000 divided by 100 square meter, which is 10 times 10 square meter. So 100, 10,000 divided 100 is what you need 100 of plants also for a hectare. So for quincunx or diagonal system, it makes use of a square with an additional tree in the center and a maximum area utilization during early growing and fruiting years. So the fifth tree usually removed when tree become large or overcrowding. And this is ideal for mechanized culture operation, which is difficult, especially in sloping areas. So it just diagonal, no? It's for diagonal quincunx or diagonal just means it's just like a diagonal shape. So the computation also differ from the square, and you have here the number of plants is equal to area over the planting distance in square meter plus the length of the area, the length in area, and over the planting distance minus 1, and times the width in an area over the planting distance minus 1. So that's how you compute for the quincunx. So the same as shown on the previous one, but there is just difference on the planting distance. So you have to guess the length and the width of the area minus 1 on the planting distance. So for a hexagonal or triangular, trees are planted at equidistant to one another from every direction to form an equilateral triangle, and greater number of trees per unit area because of the triangular form. And you can plant filler trees, which become not favorable later. So for hexagonal or triangular computation for number of trees, we have this formula. The number of plants is equal to the area over the distance of planting in square meter times 0.866. So that's given number already. So these are the planting methods for lowland rice. So for those where we have discussed earlier are for upland crops. So for lowland rice, you need to have transplanting. This has already been shown to you on the previous video, so just a matter of review. So second is direct seeding on the puddle soil for lowland rice, and you also have dry seeding or submerged after seedling stage. So this is the transplanting stage, the direct seeding, and the dry seeding. So another method for lowland rice planting is the wet bed method, wherein you pre-germinate seeds sown in seed beds and with using 50 kilogram per 400 meters square for a hectare. And it's transplanted in the field at 25 to 30 days after sowing. So you have seen this before on the video. Well, we also have the dapple method wherein seeds sown in concrete pavements like this on the figure, using 50 to 61 kilogram per 40 square meter for a hectare, and it's transplanted in the field after 10 to 14 days after sowing. And we also have the dry bed method. This is good in rain-fed areas. and seeds sown in dry seed bed with 1.5 meter wide, using 50 kilogram per 500 meters square for a hectare, and transplanting in the field 25 to 35 days after sowing. So, and the very common before, the broadcasting, wherein pre-germinated seeds sown in padded soil immediately for using 50 to 100 gram per hectare. So direct siya. No more nursery plants or seedbed or dapog method. You just directly broadcast the seeds. Pre-germinated, of course, meaning you have to soak it for 24 hours or more. So another one is row seeding, wherein pre-germinated seeds drilled in rows with 25 to 30 centimeters spacing, using the drum seeder and using 50 to 100 kilogram seed per hectare. And also drilling in rows, wherein seed drills in rows with 25 to 30 centimeter spacing using drum seeder and 50 to 100 kilogram seed per hectare. So those were the different methods of planting for lowland rice. Now for asexual propagation. So last time we talked about sexual propagation of plants, more on sexual propagation. Now, there are two types of asexual propagation. When we say asexual propagation, this could be artificial or natural. When we say natural, is vegetative propagation. We don't use the seed because it's sexual. And although in our previous lessons, although in sexual propagation wherein you use the normal reproductive organs of plants, and you use seeds, there are also instances wherein there is parthenocarpy or apomixis. So wherein the it is still it's still sexual, but then it doesn't come really from it's only come from the nucellar tissues, not really from the pollination. So same true with asexual propagation. Asexual propagation is not always artificial. There is also natural using vegetative propagation and artificial vegetative propagation. So what are these? So natural vegetative propagation can be done by using roots, stem, leaves, and reproductive organs. So roots example are radish, carrot, dahlia, and tapioca, and tuberroots, and it will develop adventitious buds which grow into leafy shoots called slips, and woody plants such as Albizia jalebek, Dalbergia siso, the roots running just below the ground level develop adventitious buds at intervals. And when stem using aerial weak stems like runners and stolons of strawberries, when touch the ground, give off adventitious roots. And in connection with the parent plant is broken the proportion with the newly struck roots develop into an independent plant. So examples are the stolons of Vallisneria and strawberry. We call it offset for echinoria and rhizome for banana and ginger, bulbs for allium, cepa, and onion, and corms for colocasia, and tubers for potato. These are all stems. So these are the adventitious roots using the node, as you can see, and these are the shoots coming from potato tubers, from corns, and the onions. Okay. So another planting materials for annuals using vegetative planting materials, we have stem cutting, which are matured stems with nodes and internodes for sugar cane, sweet potato, cassava, and forage grasses. And tubers, which are underground stem of white potato. And we also have bulb, leaf, bud comprised of clustered leaves, underground stem like multiplier, onion, and garlic. And corms, underground solid stem that contain nodes and internodes cut into several pieces like taro, banana, and avocado. We also call rhizome. It's a subterranean root-like stem that have roots in lower portion and shoots in the upper portion, like garami and ginger. That's what we call ginger rhizome. And we also have runners, growing stem that arise from leaf axils and form roots for strawberry and black pepper. And sleeves for pineapple and cabbage, which are leafy shoots originating from axillary buds born at the base of the plant or fruit. We also have suckers for banana and abaca. These are adventitious roots that arise from underground stem. And we also call corms even for banana, gladulus, and abaca, which are underground solid stem that contain nodes and internodes, which are cut into several pieces. So we use corms for tissue culture. And root cuttings for breadfruit, and leaf bud cuttings from axillary buds in stem like black pepper and vanilla. So another one, stem cuttings, which are mature stem with 2 to 3 nodes and internodes for siniguelas, macopa, grape, black pepper, vanilla, and capo. And ASEXUAL materials from layerage, marcotting, grafting, and budding. And we also call plantlets if they are derived from micropropagation or tissue culture from embryo, endosperm, mature seed, stems, shoots, tips, and root tips, meristems, single cells, and pollen grains. For example, for banana, orchid, citrus, bamboo, rattan, and makapuno. So those are the different stem cuttings, no? And now for the list, we have, I know you know it's katakataka or bryophyllum plantlets. These are from the leaves, no? Which are still attached to the mother plant. So you can detach this and a new plant will arise. So another vegetative reproduction using reproductive organs are the bulbils, no? For agave. So they are modified structures. They are fleshy storage food in the floral leaves. And once dropped from parent plant to the ground, they give out adventitious roots and develop into new plants. So there are actually terms associated per different plant, no? We have like for rhizome, it's used for ginger, no? Or gingiber officinale, and it's a runner for oxalis. These are underground stems, no? Like rhizome, tuber, corm, and bulb. And tuber, we have potato, corm, we have amorphophallus, and bulb, we have onion. And for subaerial stems, we have runners like oxalis, offset echinoria, stolen colocation, sucker chrysanthemum. And for aerial stems, we have tendril for passiflora, and thorn for carissa, phylloclade for opuntia, and cladode for asparagus, and cladophills for asparagus also, and bulbil for agave. So those are the different terms which are very specific for a crop. So we have artificial propagation. So those mentioned earlier are natural vegetative propagation. And when we say artificial, these are combining the good qualities of 2 different varieties. And the propagation is because we need to propagate the desirable variety of plants economically with less attention and comparatively shorter time. So this includes cuttings, layering, grafting, Gootee, micropropagation. So what cuttings is a vegetative portion from a plant taken and rooted in the soil to form new plants. So stem cuttings in sugarcane, roses, cropland, hibiscus, citrus, and bougainvillea, and are applied with hormones, which leads to the quick formation of adventitious roots. And root cutting from lemon, tamarind, and also develop roots and shoots when planted in a moist soil. So simply as that. So earlier we know that cuttings is also a type of natural vegetative propagation. And we have mound lower layering, when you use lower stem branch of a plant defoliated partially and bent close to the ground, pegged and covered with moist soil, and growing tip remains above the soil surface. After a few days, the covered portion of the stem branch develops the adventitious roots, and the branch is then detached from the parent plant and grows into an independent plant. So example is the jasmine, strawberry, and gooseberry. So this is the simple layering or mound layering example. So air layering is where the stem is girdled or given a slit at an upward angle, then covered with moss or cotton and wrapped in polyethylene sheet to preserve the moisture. After a few weeks, adventitious roots arise from the injured part and branch along with the roots is then separated from a parent plant and planted to grow a new plant. So that's air layering. Now we have vegetative reproduction by grafting. So the union of the stalk and the scion is carried out with the help of eustelic plants, or we call cambium. So the scion is a small shoot bearing one or more buds, and the stalk supplies the water and minerals to the scion, while scion forms the upper portion and supplies the organic food to the root. This is being done in rubber, apple, pear, citrus, mango, guava, and routinely propagated by grafting. So these are the types of grafting. We have the tank grafting, the wedge grafting, the crown grafting, the approach grafting, and the bag grafting. So tank or slicer wave grafting is the oblique sloping cut or notch given to both stack and sign of the same diameter, as shown on the figure here. No? This is the tank, so oblique. And we have the wedge or cleft grafting. It's a V-shaped notch and is given to stockwell wedge-like cut is given to the sign of same diameter. So next is the crown grafting, wherein many signs are selected and shaped at the base to form wedge, and many slits are formed on the sides of the stock, and scions are inserted in the slits and band-aids. So the stock has large diameter than the scions, and as shown on the first figure, and I also have a video to show you some example. We also have the approach grafting, wherein the two independently growing plants are brought together and the shoots of the two are given cuts at the same level for a distance of about 2.5 to 5 centimeter, and the cuts are in the form of smooth slice of bark or tongue-shaped cuts or deeper vertical cuts. The scion is then cut below the graft, while stock is cut above the graft after the establishment of union. So this is the inarching, or the other term for approach grafting. So these were the steps mentioned earlier. It's a slit, and then you approach the slit, and then you tightly bind, and after a few weeks, grafting union heals and it can be cut already to form a new plant. So another type of grafting is the bud grafting, wherein the scion is a bud with a small piece of bark and cambium. Stock is given a T-shape cut, and bark is used to expose the cambium, and bud is inserted at the bark. It's allowed to come back to its original position where only the bud is exposed, and the joint is treated with a grafting wax and bandage, and it sprouts after 3 to 5 weeks. So this is an example of the bud grafting, and this is practiced in apple, peach, and rose. Another is Gootee or Marcotting. It's also the same with air layering, but it's more commonly used as Gootee or Marcotting, wherein the bark is sliced in a ring form about 3 to 5 centimeter in length, and a thick plaster is this one, made of clay, cow dung, finely cut hay, and water to wrap up with a rug and tied on the debarked portion. So it should be moist, and after 2 to 3 months, the roots emerge from the Gootee and cut below the plaster for propagation. And this is very good in lemon, orange, guava, and lychee. So micropropagation or plant tissue culture technique is one of the latest biotechnology form of plant propagation, and it's very important, especially for banana production, because it's for mass production. The small amount of tissue from a suitable part of the parent plant is excised and grown on a nutrient medium under aseptic conditions. The tissue then develops into undifferentiated mass of cells called callus, and a small portion of the callus tissue is transferred to another suitable nutrient medium where they develop and differentiate into small plantlets. So these plants, on being transplanted into pots or soil, develop into mature plants. So this is an example of the banana tissue culture for banana. This is the initiation stage. I'm sorry for the diffracted pictures. So this shows that the young banana plantlets. So when take note, when a plant is came from tissue culture procedure, so we call them plantlet, not seedling. So this is what is done for tissue culture until the nursery stage. So anyway, there's a video to show you on that. So why tissue culture is more advantageous actually, because you can mass produce them with an indefinite number of plants from a small mass of parental tissue. So instead, if you need thousands of hectares from different companies and you need like millions of seedlings, you can readily produce that for about 6 months. No? And it is useful for obtaining virus-free healthy plants, because you need to make use of a healthy and disease-free planting materials in an aseptic condition. So most probably you're gonna produce a virus-free healthy plants. An unlimited number of plants are produced within a relatively short of time. So as I've said, you can produce thousands from a sucker in just about 6 to 8 months. So another advantages of a vegetative propagation, it will make possible propagation of plants that have lost their capacity to produce seeds. Like for banana, we know that banana is a seedless and grows. So using vegetative propagation is the best for them. And Bermuda grass or Sinodondactylon, which only produce small seeds, so they are actually propagated vegetatively. And it's more rapid, easier, and cheaper method. So some more advantages are they will produce same characters and hereditary potentials as the parent plant because they are vegetative propagated. And beneficial characters will also be preserved the next generation. Unlike for pollination and sexual reproduction, wherein a new there is no guarantee of the same characters from the mother plant, but it's actually a new combination, open pollinated plants. So most of the ornamental plants are propagated by vegetative reproduction. Grafting enables the physical and physiological joining of two separate individuals for the best economic advantage. For example, we all know that the kamatis and kamlong, we call it kamlong, is also possible. But you graft tomato as scion and you use the eggplant root as rootstock. So can you imagine that? It's more advantageous. So it is a method to get rid of pathogen also from any other plant. And very important for plants with reduced power of sexual reproduction, long dormant period seed of poor viability, and is the only way of propagation of the plant. So if you imagine if the seed can be dormant and it has a very hard seed coat, so vegetative propagation is the best way. And neither can good qualities be introduced nor can bad characters be eliminated. And subsequent generations show general fall in vigor and vitality. Adaptability to change environment decreases due to the absence of aerations, and overcrowding and severe competition among the daughter plants result in low yield. So these are the disadvantages of vegetative propagation, however. So that's all for sexual reproduction, and I'll be showing you videos on about sexual reproduction, asexual reproduction rather. So last time actually I have shown you the different asexual reproduction, this one. So I'm going to show you now grafting solanaceae and grafting tomatoes.
Of course, not all members of the cucumber family will make good grafting subjects. Here are some of the cucurbits which we found would not function as rootstock or scion. These species all failed in our trials. As we saw in Volume 4 on tubers and tuberous roots, the family Solanaceae contains many important plants such as potatoes, tomatoes, peppers, eggplants, and tobacco. These plants of the nightshade family respond well to cleft grafting. This is a relatively easy technique and has become the most commonly used method of grafting. The most commonly used vegetable for cleft grafting is the tomato. We've selected Solanum pimpinellifolium for our rootstock variety because of the current tomato's excellent vigor, weather tolerance, and disease resistance. Recall that the tomato seeds for the rootstock variety should be sown at least a week earlier than the scion. The current tomato is especially slow to germinate, so we'll plant the seeds a full 3 weeks before planting the scion. The rootstock of the current tomato should be ready for grafting when it has 6 leaves. The scion variety we're using, called Carbon, will be younger than the rootstock and should only have 4 leaves. But no matter how many leaves the scion or rootstock have, we still need to match the thickness of the stems. Tomatoes are susceptible to a wide range of diseases, so we'll want to keep our work area sanitized and use a new razor blade for each graft.
So it's simple, right? And amazing. So you can actually try this at home actually. So it's very interesting. Now in continuation for the grafting tomatoes, I will show you a separate or another video. Okay, so that's another way of grafting the tomato, and you already know on the videos that how important and why do we need to graft tomato, and that is to increase yield and use more resistant varieties of tomatoes. So, but don't get wrong, that is not an alien. There's just another hand holding to help the grafting. So another grafting done in also here.
Citrus grafting. This is my 4th video. I took a tree that I previously tried to graft and the graft didn't work. So I cut it off below the tape and I'm trying again. I split the wood just like I always do. I kind of went off, so it ended up with a little bit of a veneer graft. Taped it up. After the tape, I'll put the plastic on it. And I'm gonna have to wait 3 weeks to see how it works. When it's done, it should look like this with a little bit of new growth coming out of it. This is a graft on the right of a grapefruit that I done last year. It's growing so good that I'm putting some grafts at the end of the grapefruit to keep it from growing too fast. There I'm inserting a blood orange into my grapefruit. And the grapefruit is grafted onto a navel orange. Okay, here I'm attaching another blood orange. And after I got them all done, I'm going to wrap them together in one single plastic bag to keep them for 3 weeks, and then we'll see how they turn out. Also put some honey bells and some lemons on this tree. When you've got irregular shaped one size, this is how they all turn out. As long as you got one side good, doesn't matter if the other side's too big or not. Here's some previous ones.
Okay, so that's also pretty amazing. Seeing knowing that you can also graft citrus or any other crops while attached or while growing, no, and attached to the mother plant. So another one is budding method.
Eso que está haciendo Ren es para la claridad, para ver mejor hasta para herir el árbol. Esta ya es la heridita para insertar la yema, ¿no? Y sacar la yema.
Pues hermano, aló, ¿de qué está lo peor? De septiembre, claro, ¿cómo te va? ¿Cómo?
Ahí está, ahora solo falta el amarrado. Ese es el amarrado para que permanezca la yema en el puesto que se colocó y se pegue ahí.
¿Ah? No te creo,
y pues crece atrás del plástico sin problema.
Crece hasta cierto punto, un brotecito de 1 centímetro, tal vez. 2 centímetros.
Okay, so that's how budding is done on cacao. So, and last one I'm going to show you is another amazing crown grafting that is done here. No, wait, this is, Yeah, this is the video. So that's crown grafting, and it's an apple tree. But you can also try that in some other types of fruit crops or trees. So you can use wax or carbon-based materials to actually get rid of infection from microbes and to seal as well. So there are also a lot of ornamentals that you can use. So you can, enjoy in one particular pot of plant, you can enjoy the different colors of bougainvillea, for example. So you can do that in a bougainvillea or in some other woody stems, or as big as that, as shown on the video. So um, not only you can get different, as long as they are of the same family, like for mango, you can use different, as long as they are on the same family, on a card to say, so you can actually um, craft or bud different varieties of mango in one tree. So that also happens with a lot of colors in bougainvillea tree. So you notice the stems on the middle are just used to hold the seed while preparing the cyan to be inserted later. And again, you have to use base or wax, carbon-based, to seal and to get rid of microbial infection. So that's how crown grafting is being done. So I still have two videos left. So I would just post this on your Google Classroom on about banana tissue culture and preparing tissue culture, and hopefully you will watch it, during our asynchronous time left. So thank you very much for watching this video, and I hope to see you again on the next class or video.